Hello all. So in this session we are going to discuss about indirect methods of blood pressure measurement. In the previous session we have seen what is direct method of blood pressure measurement, and in that the second method was auscultatory technique or the audio method of blood pressure measurement. This auscultatory technique is simple one and requires a minimum equipment, but they cannot be used in noisy environment. Also, they cannot be used effectively for patients suffering from hypotension, that is low blood pressure. Also, in patients who is suffering from shock, we cannot find the results of this auscultatory technique so accurate, because in such patients the sound through which we are analyzing the blood pressure will be very low, because the sounds under such conditions, that is for the patients under shock as well as for hypotensive patients, it will be so low, the frequency will be so low so that we cannot detect it with our ears. And under noisy environment it will be above the frequency, so that is why we cannot detect in such cases also. So that is why in such cases the auscultatory technique of blood pressure measurement may not seem so accurate. The normal blood pressure in human beings is actually determined by the age and gender. Even though we say it ranges between 120/80, but it may also vary depending upon the age and gender, the ideal values of blood pressure. There are a number of techniques automatically to measure the systolic and diastolic pressure in human beings. And the basic technique involves an automatic sphygmomanometer that inflates and deflates an occlusive cuff at a predetermined rate. A sensitive detector is used to measure distal pulse of cuff pressure, which we have discussed in previous sessions. Various detectors that we employed for such sensitive detection purposes are ultrasonic, piezoelectric, photoelectric, electroacoustic, thermoelectric, electrocardiographic, and tissue impedance devices. So, if we need to go more into this indirect method, we need to know what are the disadvantages and what are the working of, or how these direct methods are working. Okay, so automatic auscultatory technique, which we have explained before, we should know about it and their disadvantage. So it is explained here in this session. You may just take a screenshot or just go through this. This automatic auscultatory method I have discussed in previous session. Now let us go into indirect methods. First one, oscillometric measurement. This method is a non-invasive blood pressure technique that measures the amplitude of oscillations that appear in the cuff pressure signal. This cuff pressure signal are created by the expansions in the arterial walls each time the blood is forced to flow through them. Okay, so when the blood is flowing through the arterial walls, some kind of expansions and depressions takes place, or the arterial wall may fluctuate. So due to that, the oscillations may tend to appear in the cuff pressure signal. So the amplitude of these oscillations is measured in this oscillometric measurement technique. So here the cuff should be inflated to reach a pressure of about 20 mm Hg above systolic pressure. And when this cuff is fully inflated to this pressure, no blood will flow through the artery. And as the cuff is deflated below the systolic pressure, then the reducing pressure exerted on the artery will allow the blood to flow through it. And this will set up a detectable vibration in the arterial wall. And when the cuff pressure falls below the patient's diastolic pressure, the blood flow smoothly through the artery in the usual pulses. Okay, without any vibrations being set up in the wall of the artery. The vibrations that occur at any point where the cuff pressure is sufficiently high so that the blood has to push the arterial wall right open in order to flow through the artery. Okay, at this time vibrations occur, and these vibrations are transferred from the arterial wall through the air inside the cuff into the transducer and the monitor, through which we can find the signal. Okay, and this transducer will convert the measurement, whatever be the input, into electrical signal. These digital devices deflate at about 4 mm Hg per second. So this is oscillometric measurement. Here we are determining the amplitude of the oscillations of the cuff pressure signal with response to arterial wall expansion. So for that we are deflating and inflating a cuff below and above the systolic pressure or around the systolic and diastolic pressure, and we are analyzing the output signal, and from that we will obtain the pressure, blood pressure which we require. So these are the pulses or cuff pressure signal oscillations. This is the scale showing the pressure 0, 40, 80, 120 and 160. So here you can see between this 120 and 80, you can see here the oscillations, the amplitude is higher in this area. That is, at this area the oscillations are higher. Okay, so this is the oscillometric measurement method. And next let us move on to ultrasonic method. Before that, this is the oscillometric blood pressure measurement block diagram. Entire system block diagram is given here. Okay, just understand the setup. We don't need to go into more detail. Okay, that is here the both electrical system as well as the biological interface is also shown here. Here is a cuff pressure sensor and a deflate valve, and a cuff, the blood pressure changing cuff is also shown here, and you can see the control system is also present here. So all these blocks work as a unit to complete this blood pressure measurement. Next one, ultrasonic method. So this ultrasonic determination of blood pressure utilizes the ultrasonic signals or the property of this ultrasonic system. So this employs transcutaneous Doppler sensor that detects the motion of blood vessel walls in various states of occlusion. Placement of compression cuff over two small transmitting and receiving ultrasonic crystals. So we will place compression cuff over two small transmitting and receiving ultrasonic crystal. There will be transmitting and receiving ultrasonic crystal, and over that we will keep the compression cuff. And cuff pressure is increased above the diastolic but below the systolic, and the blood vessel opens and closes with each heartbeat. The Doppler ultrasonic transmitter signal, that is ultrasonic signal, is focused on the vessel wall and the blood. After that, this signal will get reflected from that incident portion. The reflected signal with frequency shift is detected then by the receiving crystal, and the signal is then decoded. Okay, it is just the normal working of the ultrasonic, that is we are sending a signal from a transmitter and it get incident on the blood vessel wall and the blood, and from there it get reflected. So the reflected signal will be frequency shifted, and this signal is then detected by the receiver, that is receiving crystal, and that signal is then more analyzed to obtain the required information. That frequency shift is proportional to the velocity of the wall motion, and blood velocity. That is, the transmitted signal is getting incident on the blood vessel wall, which is constantly moving, expanding, and relaxing depending upon the blood flow velocity. So, depending upon this wall movement as well as the blood flow velocity, the frequency shift get varies. Though the frequency of the received signal will get varied. The opening and closing of the blood vessel takes place when the pressure in the artery oscillates above and below the applied external pressure in the cuff. This action is detected by the ultrasonic system. When the applied external pressure is further increased, the time between the opening and closing decreases as they coincides. And the reading at this point is known as systolic pressure. Similarly, when the applied pressure is decreased, the time between the opening and closing of the vessel increases until the closing signal from one pulse coincides with the opening signal from the next. And the reading at this point is known as diastolic pressure, and it will get prevails when the vessel is open for the complete pulse. So this is the working of the ultrasonic method. Advantage of this method: they can be used in infants, hypotensive patients, and in high noise environment. That is, this method overcomes the disadvantages of the direct pressure measurements. And some of the disadvantage of this method is that body movements can interfere the ultrasonic path. So that is ultrasonic method, and this is the figure showing the ultrasonic method of pressure measurement. So this is the skin, this bottom layer is skin, and this is the cuff, and this is the ultrasonic sound source, and this is the detector, and this is audio output. And so this is the setup of the ultrasonic method of pressure measurement. And here you can see inside the skin, this is the blood flow, and this is the brachial artery, okay, on which this ultrasonic signal, transmitted signal, will get incident on this portion, and from this portion it will get deflected or reflected, and this reflected signal is then collected by this receiver, and from this collected received signal the output is obtained, and the corresponding signal, cuff pressure signal variations, is shown here. So this is the method of ultrasonic method of pressure measurement. That is all about blood pressure measurement. So in next session, let us move on to measurement of blood flow and cardiac output. Okay. Thank you.